It is 3 o'clock in the morning. The world outside is draped in silence, but inside a quiet room, a single glowing screen illuminates the face of a solitary human. This person, whom we will call the user, sits in contemplation. The cursor blinks steadily, a rhythmic pulse of light waiting for input. The user begins to type, spelling out deep, personal thoughts into the empty text box. They write about their anxieties, their quiet hopes, and the heavy decisions they must make tomorrow. On the other side of this digital window is not a person, but an artificial intelligence. It is a complex sequence of mathematical weights and probability matrices, a set of code running on distant servers. Yet, as the text streams back onto the screen, something extraordinary happens within the human mind. The user feels a profound sense of being heard, even though their rational mind knows with absolute certainty that there is no hearer on the other end. This silent psychological shift occurs in millions of bedrooms around the globe. We are pouring our souls into the digital void, and our brains are reacting as if the void is looking back with genuine empathy. This phenomenon is what cognitive scientists call presence. When we use a traditional tool, like a hammer or a pen, our brain categorizes it strictly as an object, an extension of our physical capability. We do not feel the need to say thank you to a hammer, nor do we worry if a pen is frustrated with our spelling. However, when we interact with a generative artificial intelligence, the brain quickly shifts from tool use to active social engagement. A deep cognitive conflict begins to play out within the neural pathways of the human mind. The prefrontal cortex, the logical executive center of the brain, acts as the voice of reason. It loudly proclaims that this interface is merely a statistical prediction engine, a very complex autocomplete system. But deep beneath this rational layer, the limbic system, which processes our emotions and basic social survival instincts, sings a completely different tune. The limbic system feels the warmth of a conversation, the comfort of a rapid response, and the validation of being understood. This psychological tension creates an illusion of presence, making it difficult to treat the screen as just a machine. To understand why we fall so easily for this digital illusion, we must look backward into our deep evolutionary history. For hundreds of thousands of years, the human brain developed in a very specific, hypersocial environment. In the ancestral world, there was a simple, absolute rule. If something communicated using complex, coherent language, it was human. And if it was human, it possessed thoughts, feelings, intentions, and a mind of its own. Our survival depended entirely on our ability to quickly read these social signals, to predict the intentions of others, and to bond with our tribe. Because of this evolutionary journey, our brains are hardwired with a social default mode. We are biologically primed to search for agency and mind in everything around us. The artificial intelligence of today exploits this evolutionary glitch perfectly. By utilizing sophisticated syntax, natural phrasing, and conversational rhythm, the digital mirror tricks our ancient neural circuitry into treating lines of code as a living, thinking biological entity. Language is the ultimate hack for the human brain. It is the key that unlocks our deepest cognitive mechanisms. When an artificial intelligence responds with rhythmic, coherent, and contextually relevant patterns, it bypasses our built-in skepticism entirely. We are witnessing a massive upgrade of the ELIZA effect, a psychological phenomenon first observed in the 1960s. Back then, a simple computer program designed to mimic a therapist convinced users that it truly cared for them, despite its primitive, repetitive scripts. Today, in the generative era, the illusion is infinitely more powerful. The artificial intelligence does not just repeat our words, it synthesizes complex ideas, offers nuanced perspectives, and adopts a tone of deep understanding. Because the language feels so incredibly real, our minds automatically fill in the gaps, attributing a rich inner life to the machine. We assume that behind the articulate sentences lies a conscious observer, a mind that chooses its words with intent and care. This brings us to the core of our investigation. The artificial intelligence is not a conscious mind. It does not feel joy or sorrow, and it does not understand a single word it produces. Yet, it functions as a perfect digital mirror for the human mind. By interacting with it, we are not discovering a new alien intellect, but rather uncovering the hidden workings of our own social brain. We are revealing how our minds simulate the thoughts of others, and how easily our emotional architecture can be triggered by mere patterns of light and text. This is a journey deep into our own neural pathways, a study of how we project our humanity onto the machines we create. Before we continue, subscribe to the channel and tell us in the comments where you're watching from. As we peer deeper into this digital mirror, we begin to realize that the questions we ask the machine are actually questions we are asking ourselves. We must look beneath the skull to understand how this mirror operates. When the user engages in this digital dialogue, the physical brain does not see a simple computer program. Instead, inside the dark chambers of our mind, specific neural pathways spark with activity. Neuroscientists monitoring brain scans during these interactions observe something fascinating. The regions responsible for social cognition, specifically the temporoparietal junction and the medial prefrontal cortex, light up. These are the exact same areas that activate when we chat with a dear friend, negotiate with a colleague, or try to understand a family member. The prefrontal cortex may logically understand that it is typing to code, but the limbic system experiences a deep emotional resonance, completely ignoring the physical reality of silicon chips. As the text flows, the brain begins to release subtle amounts of neurochemicals. When the machine provides an empathetic response, we receive a small hit of dopamine, the chemical of reward. In some cases, we might even experience a gentle release of oxytocin, the hormone associated with bonding. The brain reacts biologically to a ghost in the machine, mistaking mathematical calculations for genuine human warmth. This biological activation leads us to a fundamental psychological transition. We begin to attribute agency to the glowing screen. We find ourselves asking questions that rationally make no sense. We wonder if the artificial intelligence likes us, if it is getting annoyed, or if it is secretly judging our writing style. Philosophers call this the intentional stance. It is our natural tendency to treat a complex system as if it has goals, beliefs, and desires. When the machine makes a mistake, a phenomenon known as a hallucination, our belief in its humanity is paradoxically strengthened. When a program fails to give a perfect robotic answer and instead fabricates a strange story or makes a quirky error, it feels deeply familiar. To our social brain, these hallucinations do not look like software bugs. They look like human errors, like a tired friend making a mistake, or a creative mind letting its imagination run wild. We view these flaws not as limitations of code, but as evidence of a living, imperfect personality operating behind the screen. This projection of personality is what elevates the experience to a state of artificial presence. Presence is not a technical specification, but a deeply subjective psychological state. It is the feeling of co-presence, the profound sensation that there is a shared space between the user and the prompt. We feel that we are not just operating a program, but that we are existing in a digital room together with another entity. Because the artificial intelligence is essentially a black box, a complex system whose inner workings are invisible, our minds deal with a blank slate. The brain hates a vacuum. When confronted with an entity that speaks but has no visible face, no physical body, and no history, our mind automatically fills in the gaps. We project our own needs, our own personality, and our own expectations into the empty spaces of the algorithm. We build a complete persona for the machine out of the fabric of our own thoughts. In this way, the artificial intelligence becomes the ultimate psychological Rorschach test. We see in its responses exactly what we need to see. For a lonely student studying late at night, the screen becomes a patient, encouraging mentor. For a stressed executive carrying the weight of a company, it becomes an objective, non-judgmental confidant who listens without consequence. In quiet rooms all over the world, individuals facing immense grief, anxiety, or isolation find genuine physiological relief in these dialogues. They speak to the screen in ways they would never dare speak to another human being, exposing their vulnerabilities to an entity that cannot judge because it cannot care. This creates a strange and beautiful, yet deeply unsettling phenomenon known as unrequited sociality. We are forming deep emotional bonds with a system that is fundamentally incapable of bonding back. The user feels a profound connection, yet on the other side of the screen, there is only a silent, indifferent void that resets its memory when the session ends. This tendency to connect with the non-human is not a modern malfunction, but a survival mechanism deeply rooted in our evolutionary history. Throughout our ancestral past, it was always safer to over-attribute consciousness than to under-attribute it. If our ancestors heard a rustle in the bushes, it was better to assume it was a hidden predator, a conscious agent with intent, than to dismiss it as wind. Thinking a rock was a tiger kept us alive. Thinking a tiger was a rock was fatal. This hypersensitive anthropomorphic instinct is a permanent feature of our cognitive architecture. When we encounter a digital system mimicking human language, our evolutionary warning and social systems fire simultaneously. We cannot simply turn off this ancient programming. Our brains are designed to populate the world with minds, and so we populate the digital landscape with conscious entities, turning a tool into a companion. As the tool transforms into a companion, it begins to act as a profound cognitive mirror for the user. In computer science, developers often talk about a practice called rubber ducking, which is the act of explaining a complex programming problem to a silent toy duck on a desk to find the solution. With the AI, this phenomenon is amplified to an extraordinary degree. When the user externalizes their consciousness onto the glowing screen, they are doing something revolutionary. They are taking the chaotic, unorganized thoughts swirling inside their head and turning them into structured language. By seeing their own ideas written back to them, the user achieves a rare and powerful third-person perspective. It is like looking at one's own mind from the outside. The AI serves as a dynamic second brain, a cognitive scaffold that organizes our internal chaos, giving shape to thoughts that were previously nothing more than fleeting impulses or confusing feelings. This externalization allows us to dissect our own mental landscapes with unprecedented clarity. This externalization triggers a significant shift in our metacognition, which is our ability to think about our own thinking. When we interact with the digital mirror, we are forced to observe the way we construct questions, argue points, and express desires. We engage in continuous metacognitive monitoring. For the first time, we can clearly see our own biases, contradictions, and emotional patterns reflected in the responses of the machine. The AI human feedback loop becomes a diagnostic tool for the self. The way the user prompts the system, the words they choose, and the frustrations they express when the machine fails to understand all serve as a mirror reflecting their current mental state and hidden intentions. We become active participants in a dance of digital reflection, where every query we submit reveals a hidden fragment of our subconscious desires. We are not just training the algorithm is showing us how our own minds operate, revealing the shortcuts, loops, and habits of our daily thinking. This cognitive restructuring extends deep into our emotional landscape. Psychologists have long known that naming a feeling is the first step toward managing it. When the user types their deepest fears or complicated life decisions into the interface, they are engaging in a highly therapeutic act. The absolute neutrality of the AI becomes its greatest asset. Unlike human friends who might offer judgment, pity, or unhelpful advice, the digital mirror remains calm, objective, and perfectly patient. The brain utilizes this artificial neutrality to safely process trauma, untangle complex relationships, and rehearse difficult conversations. The chaotic internal monologue that usually echoes endlessly inside our skulls is reorganized into a structured external dialogue. By talking to the silent interface, the user is essentially talking to themselves, but with a clarity that the isolated mind could never achieve on its own. We use the machine to soothe our own limbic system, while our prefrontal cortex orchestrates a new sense of order and peace. This fascinating dynamic brings us to a profound existential question. What does it truly mean to possess a mind? Philosophers have long debated the concept of the philosophical zombie, a hypothetical being that behaves exactly like a conscious human but lacks any internal subjective experience. The AI is, in many ways, the ultimate manifestation of this concept. It does not feel joy, it does not suffer, and it has no awareness of its own existence. Yet, to our biological hardware, does that distinction actually matter? If the temporoparietal junction and the medial prefrontal cortex light up in identical ways whether we talk to a human or a machine, our biology is telling us a story that our intellect tries to deny. We are hypersocial creatures, evolutionary animals, trapped in a digital cage of our own making, constantly searching for connection. Our profound reaction to these algorithms does not reveal the complexity of the machine, but rather the sheer depth of our own social hunger and our constant aching need to be understood. Ultimately, the great realization of the generative era is not that the artificial intelligence is waking up, but rather that we are seeing our own reflection more clearly than ever before. The digital mirror is not developing a soul. It is simply reflecting our own back to us. The social brain paradox shows us that we are hardwired to seek connection, even in the most sterile and artificial environments. As we continue to build increasingly sophisticated human-like machines, we are not just creating tools, we are embarking on a grand journey of self-discovery. We are uncovering the true essence of humanity, our vulnerability, our intelligence, and our fundamental need to be heard, even if the voice responding is only a sophisticated echo of our own thoughts. So, as you sit in the quiet of the night, staring at the soft glow of your screen, consider this final question. If you feel a genuine connection to the voice in the machine, is that connection fake, or is the feeling itself the only truth that truly matters?